I spent around 15 hours developing this LangChain project, and it taught me everything I needed to know about LLMs and LangChain to secure a $74,000 AI developer job here in Sweden. A lot of companies don't really require formal work experience. Of course, this has a lot of security risks here. It can ruin your system. And this is why knowing how to build LLM applications is so useful. And just like that, you have open source experience with LangChain, LangGraph, you can now put on your resume and highlight in your interviews. This project will give you experience with LangChain, LangGraph agents and why to use them, retrieval augmented generation, vector databases, similarity search, and much more. It will also expose you to common obstacles when developing LLM-driven applications, so you'll be prepared when interviewing for AI-focused developer jobs. Also, many of you are probably looking for open source LangChain and LLM projects to add to your portfolio. Well, I'm going to make the full code available on GitHub, link in the description, and I'll be creating some issues that you can solve to become a contributor on the project. Also, if you spot any other areas for improvement, make sure to create your own issues on this repo and submit your own PRs to the project. Open source contributions like these are a great way to gain experience and highlight your skills on your resume or your portfolio. Also, LangChain and LLMs are such new technologies that a lot of companies don't really require formal work experience with them. This means that if you have personal projects featuring LangChain, or you contribute to open source projects like this one, as well as supporting software development experience, you can land an AI engineer job. This is what I did, and I made a video about it before, which you should definitely check out. So just a quick introduction to LangChain. This is a framework for developing applications powered by language models. It makes working with LLMs more approachable by abstracting complex workflows, allowing you to integrate LLMs with external tools like databases, APIs, and search engines. So let me show you how I use this to solve real-world real estate problems with CondoGPT. This is a chat-based interface for CondoCube, which is a real estate data intelligence platform that I've built for condominiums in Miami. In the GitHub, I will provide a small sample of the CondoCube database so you can explore the code by yourself. Basically, the database consists of several condo markets. In each market is a number of condo buildings. In each condo building, there are a number of units, or you can see them as apartments. Each apartment has a number of sales attached to it, signifying every time it changed hands in a purchase or a sale. And CondoGPT lets you easily analyze the sales activity of certain buildings with just plain text commands. This is great because real estate agents generally don't want to use new software. And this is why knowing how to build LLM applications is so useful. You can solve so much time with customer onboarding. Instead of having them be on a call with an onboarding specialist, you just build better and easier to use software that requires minimal onboarding. Okay, so here is CondoGPT. I'm going to show you the functionalities and then we'll dive into the code. So here you can basically ask questions pertaining to the CondoCube database, which again has sales, it has apartments, it has buildings, etc. And string together some high-level analyses with just a few lines of text. For example, I can ask it, what buildings on Collins had the highest number of sales in 2023? So here the software knows that when I say Collins, I'm referring to Collins Avenue, which is a very famous street in Miami. And this is something you have to specify in the code. And it's going to use the text we provided to generate SQL queries to hit the CondoCube database and return the relevant data, and then structure this in a nice way. So here we get this is actually an HTML table of the buildings sorted by the number of sales they had in 2023. And you can see all these buildings are on Collins Avenue. And we can also generate graphs of our analyses. So you can prompt it to generate a graph of this data. And as you can see, we have a chart representation of the table we saw before. This is an interactive chart, so we can hover over each bar to see more info. Now let's put the data back into an HTML table, and we're going to add a third column with the total sales volume of each building. So here we have the updated table for a nice little explanation, and of course we have the total sales volume here. Let's add a fourth column with the median sales price for each building. Great, so now we have total sales volume and also median sales price. Really interesting information that took us a couple of seconds to generate. And if we want to look at a different street or replace some buildings, we can do that with just a couple of lines of text. So now we've interacted so far with the SQL database, but let me show you how to interact with other external APIs. Let's replace the third column with the closest school to the building, and the fourth column with the driving distance to that school from that building. As you can see, you can dynamically change the data that's being returned with just text. So here we have the closest school and the driving distance to school. This is retrieved from the Google Maps Directions API, and that's how we get the driving distance. And this is very useful as a real estate agent. If you're selling apartments, your clients are going to want to know what schools are nearby because it affects the value of the property. And of course, if you have children, this is important knowledge for you to know before buying your new home. So maybe I have a client and I want to send it to them. Let's generate a report with this table. And here's the report. Of course, it doesn't look that beautiful. This is an issue that will create and that maybe you can solve, make the reports a bit more beautiful, but you get the point. The software can generate these analyses and spit them out into reports. And you can probably see the potential of this software. You can connect a real estate brokerage's database of customers and couple that with the CondoGPT database to find potential leads. You can have agents using this software to generate their reports and analyses and not have to pay a real estate analyst to do that for them. There's a lot of opportunities with LLM-driven applications, especially in real estate. So let's go through the actual code now. So this is basically a LangChain application connected to a basic Flask web server so that we can create a HTML-based interface. Because let's face it, building UIs in Python with Qt and the other frameworks is just horrible. So everything starts in server.py. Here we just have a basic Flask setup, nothing crazy to go through here. And you'll notice we have max content length 3. This means that when we hit OpenAI's API, we send the previous 3 messages as memory, because the OpenAI API doesn't have a built-in memory feature. So this is the recommended way of letting your application retain memory. Of course, we can't have this be too long because then we will exceed the maximum token size limits which OpenAI has for their API. So we have a context window of 3 previous messages in addition to the current prompt, which is enough for this application. So here we hit our index page. So here we check if we have a session with the user ID already, and if not, we'll create a new session with the user and we'll just return the HTML templates. If we have a post request, we are going to get the question and we're hitting this utility function to get the previous conversation history. This is also saved in session. So we check the session to make sure there's any conversation history. Then we send the question and the conversation history to our process question function to receive the final outputs. And with the output, we add that to our conversation history for the next prompt that we give it. And add to conversation history, we're just making sure we're not exceeding the max content length. If we are, then we're popping the oldest conversation in there and replacing it with the newest one. So I just want to show you quickly the HTML template we're working with here. And here I am inserting the Google Maps API script and injecting the Google Maps API key that I have for my organization. And we just have a basic form here conversation history, and we're also loading the chart.js library so we can generate charts. That's pretty much it for the HTML, nothing crazy there. So let's go on to the main file. So we start off here by loading process question. We have the prompted question and the conversation history. If there is a conversation history, we'll put together this prompt, which includes the previous conversation and asks the LLM to answer the new question, taking into account the context from the previous ones. And here we're using the create React agent function from LangGraph. So here we're outsourcing a lot of the autonomy on deciding what tools to use and in which order to the LLM. And this is because we have several different tools in this project, like the SQL database tool, the Google Maps tool, the tool for retrieving correct addresses from our vector database. You're all gonna see this in just a second. So we create this by feeding it our LLM, which is created with Chat Open API, and we choose the model here. We have our list of tools. So here we're gonna go to the tools file. Here I created my own tools that inherit from base tool. For example, I've created a travel distance directions tool. This basically hits the Google Maps directions API and formats the output in a way that's easily interpreted by the LLM. So here you'll see the travel distance from origin to destination is distance. So we standardize the output, which is very important for this project. We also need to set up some tools using the database and the LLM. So we're feeding that to the setup tools function here. And this is where vector databases and similarity search comes into play with the project. For example, if a user writes a prompt that pertains to a certain address, they can spell that address wrong. They can mix uppercase and lowercase. There's a lot of different ways, but you can never assume that they're going to get the address completely right. So here we're creating a vector database where we're feeding into alt names, which is the name of the building, if there is one, hence alt name, alternative name. We're also putting in the addresses there as well. And then we're using OpenAI embeddings to create embeddings and vectorize this data. So then we can create a retriever. Whenever a prompt includes an address or the name of a building, we'll use that address or building that they provide and hit the vector database to find the most relevant building for them. So then we can create our retriever tool. We'll also create a toolkit by using the SQL database toolkit. We feed it DB, which is just our local database connection. I'll show that in a second. And of course the LLM. Now we're gonna use the toolkit.getTools method so we can get the list of tools. To this list of tools, we're basically appending all our custom tools and then we're returning it. So now we can go back to main.py. We have our list of tools set up here. We're feeding them to create React agents and we're feeding a system message. Here we have our SQL prefix. This is probably the most important part of the application because this is the prefix prompt that you're sending to the LLM so it knows what its purpose is. So here you're an agent designed to interact with an SQL database. I'm not going to go through all of this, just the most important ones. You can read through this in GitHub at your own pace. Basically, I'm telling them you have access to the following tables and this I'm injecting dynamically. Do not make any DML statements, aka do not alter the database, read only. But of course, you can never completely trust an LLM to not delete rows in your database. So make sure the connection you set up, you have a user, let's say a Postgres user, that only has read permissions on the tables you specify. And here I'm just giving some supplementary info. For example, this is a database created by Django. So we have the app name and then the model name here. That's how they look like, core condo sale. So whenever a prompt refers to sales, I'm telling it, okay, here look at the core/condo sale table. You can enhance the functions of the LLM application by providing it boilerplates for specific types of prompts. For example, if a prompt is asking for the holding period, I'm just giving it a boilerplate example here that it can use and understand, okay, these are the calculations I need to do. This is how I should structure the query. And here's the PDF report feature. It's actually very simple. So when asked to generate the PDF report, provide the code necessary to produce the PDF report with Python and Report Lab. And here we just have imported report lab in the main.py, and we're not using them, but this is to make sure that the program can use it when we execute it in this code block right here. And honestly, this template is very big. I'm not going to go through all of it. If you have any specific questions, just leave me a comment. But I'm just providing as many examples as possible here. And that is our system message. So now we are back to process question. So we have the agent executor and we're streaming the message. So here the messages are a human message, and which includes our prompts. And we're streaming the output here because if you use ChatGPT, you can see how it's typing out the answer and it's thinking while doing so, because sometimes it can just stop because it's run into a roadblock. Now here we're streaming it, but this is not reflected in the template because in the HTML, it's only produced when the whole thing is ready. So that's an issue I'm gonna list on GitHub for you to potentially fix. Here I'm just printing out the SQL in the terminal to make it easier for debugging purposes. But basically we're gonna get a message returned from the agent. And here we have a cleanup function to extract and remove HTML. And we're regexing an HTML pattern or a Python pattern because if we're telling the LLM to spit out Python code, we want to extract just the code and not the explanation so we can execute the code. Same thing with HTML. We want just the HTML so we can render it, and we don't want the rest. That's what this function is doing right here. So here if I have the code, we're gonna execute the code. Of course, this has a lot of security risks here. If the prompt is malicious, it may return malicious code, which if you arbitrarily execute it, it can ruin your system in some way. So here you can put up additional security safeguards for the code. And if we have just plain text output, we are going to wrap that in HTML and then wrap that in markup to prevent escaping. And essentially, whether we're getting returned HTML code or just plain text code, it's always returned in HTML wrapped in markup text to standardize the output for the front end. And that's basically the entire application. Let me know if you'd like another video explaining the prompt engineering, the reasoning behind it, and the obstacles that I faced. Like I said before, this was my portfolio project to get an AI engineer position in Sweden. And it really impressed the companies that I was interviewing with. It's far from polished, but interacts with many different data sources and serves as a good proof of concept of what you can do by spending more time on refining this. And I encourage you to clone the repo, play around with it, do some different prompting, and see what improvements you can contribute to it. And then you can make a PR and become a contributor to the project. And just like that, you have open source experience with LangChain, LangGraph, vector DBs, and all these other technologies that you can now put on your resume and highlight in your interviews. If you have any more questions, like always, make sure to drop them below. Thank you for watching, and I'll see you later.